Okay, there's the timer. So anyway, my name's Rogers George. I'm an iPhone developer, been doing stuff at various employers around here. When I Work is a big one. Hidrate, the smart water bottle people, is another one. And a couple others. Talking with my guys from Lab 651 here. By the way, if you need iPhone apps done, call up Lab 651, we'll do you right. Or actually many forms of software. Any kind of contractual software development you need done, call up Lab 651. If it's an iPhone project, I'll probably be doing it, 50-50 chance. And in a number of these places, I've noticed some mistakes. We've all have to deal with dates at some level, measurement of time, and my first couple big contract gigs, I made the mistakes, and then I moved on to different jobs, and I noticed that other people would make them after I learned not to, and moved on to a new place, and I'd find some new novel mistakes. And first of all, why are these mistakes happening again and again? And is there anything we can do about it? Any conventional wisdom for dealing with dates? I did a little Googling, and there's not much out there. There's a list of falsehoods programmers believe about dates, which is interesting reading as far as it goes, but it doesn't actually tell you why all these things are false, which is kind of a shame. And there's certainly very little advice on how to correctly handle dates beyond use your platform's library functions. Don't try to do it yourself. Just use the platform library functions, you'll be fine. And I mean, it's a necessary condition, but it's not sufficient. It's still totally possible to use your platform's library functions and just make a total hash of things. I see some nods. A little motivating example here. I have to keep this down to 1.5 minutes per slide, or we're going to go overflow here. This is one from, is anyone here from Hidrate? I don't think any of the Hidrate guys are here. All right. So I'll air their dirty laundry with abandon. So simple, right? How could you cram a mistake into this? I found the code examples are going to be in Swift, but this is a stand-in for a more complicated situation in the database that I encountered. There's a birthday column, and they use the date type. What's wrong with that? It's a date, right? A birth date. Except what actually got put in this thing was provided by the client apps. They would put in a date type, which on this platform happens to be a seconds offset since a particular epoch. And they just plop that in there raw, right from the user's date picker to a date. So what happens when I set up my account, put in my birthday, my user record, and then I move 1,000 miles to the west? You age back? Yeah, well, by a day, yeah, but the system doesn't know when my birthday is. I'm getting the birthday alerts at an hour off. Let's do something a little more complicated here. This is in lieu of a situation at When I Work, which as far as I know still stands today, for hour in 0 to 23. We're printing an employer's employee work schedule here. Bars and such are open at 2 a.m. What happens twice a year when there are 21 or 24, where there should be a 22 or a 24 there instead of 23? Oh, nothing good. And what's with that 30 hour times 3,600? I mean, that part of it is correct here, but that's a good code smell to look for, by the way. Assuming an hour is exactly 3,600 seconds. It often is. We'll cover that a little bit, but that's one that could vary by platform. Here's a real subtle one. This one bit us real hard at When I Work early on. All of this is correct. I get the system calendar. I ask it for a year, month, day from a user pick date. So the user's picking 3 components, and we're getting those 3 components. We ask that calendar to, we don't ask the calendar, we ask a JSON encoder to feed it to our backend. And this seemed to work, and we deployed it, and it seemed to work for everyone for months and months and months. And one person couldn't see their shifts. And they'd go in there and they'd add a shift themselves because they were a manager, and that shift was just off into the ether. What do? We relied on that bit of global shared state, calendar.auto-updating current. We trusted the user to give us a calendar that we thought they were going to give us. This particular user used the Buddhist calendar, which is exactly like the Gregorian one, except for year 0. So all their shifts were being created 2,000 years in the future. Whoops. A couple bonus ones. I've seen code that assumed today will never go backwards. Of course today could go backwards. We'll see how. That assumes that everyone has the same today. That one doesn't last contact with friends in different time zones. If Marty and I are both drinking from our water bottles, and Marty's in the India time zone and I'm in the Minnesota time zone, he's gonna win every day. You'll have 12 hours of drinking time in your today before my today even gets started. One for the Kenmore project here. There's a timestamp field in some JSON in a real application in a real situation. JSON timestamp, Friday, May 27th, 2022, 11:25 a.m. What zone? What calendar? Mm-hmm. At least we got the weekday right? So they were doing something with the timestamp. I don't quite know what. It didn't require more than 24 hours of precision, thankfully, because they sure weren't getting that. And this isn't really a date bug, but it's just a little bonus from the When I Work days. Our first Swedish customer alerted us to a problem. When a date that we were putting in the URL query string worked fine on our machine, right? An ISO 8601 encoded date has, for us, a minus in front of the time zone offset. For the Swedes, it has a plus. Do you know what your platform does with pluses unencoded in the URL? It shouldn't do anything. But PHP helpfully decides that they're a space. Whoops. Anyway, other than that last example, there's a common theme here that I've discovered. It is that you cannot freely convert between physical time and calendar time. Even though it's a lie that all the frameworks will try to tell you that this conversion is free, it is not free, and you cannot, in the general case, do it. Because date, somebody asked what kind of dates are we talking about here? Means 2 radically different things that are not fungible. There is the position in time, a nice Newtonian linear offset in a one-dimensional space. We love working with that. It's easy. It fits our intuition. It's imprecise because it's a physical quantity that a physical sensor in our computer is reporting to us. So it comes with all the pitfalls there. So it's easy and intuitive for us programmers, but it's useless for our customers. Nobody thinks of Unix time as 165.358.9547, which was the Unix timestamp when I was putting this together last week. Humans live in calendar space, specifically symbols on a clock and a calendar. And these are very human measurements, and as such they are subjective. They are different in different venues and different cultures. They change over time because many amateurs who are not well versed in horology have ascended to various royal or papal thrones and made pronouncements. And together they have formed what we technically call a mess. And these 2 things are not the same. They are almost never the same. You have a point in time can be up to 40-ish different possible combinations of calendar and clock fields. And a calendar and clock field only maps to a particular point in time if you have every single one of them, including the dangerous ones that we all like to shove off to global state. Say, oh, well, obviously we're talking about the local time zone or the local calendar, or the Gregorian calendar. Everyone uses the Gregorian calendar, right? Whoops. I said physical time is nice, and it is nice. The traditional way of handling it is as a single number that's just an offset of some unit from some agreed on fixed reference. The popular ones are the beginning of 1970, obviously. Apple uses the beginning of 2001. Julian uses a really, really old day and then counts the solar days. That one predates computers. It's nice and unambiguous for astronomical purposes. Anno Domini is not actually a good example because we don't know when our Domini was nated, or whatever the Latin word is. Herod died in 4 BC and Cyrenius ascended to the Syrian governorship in 6 AD. So, bait your window there. Pick your favorite epoch. We practically just assumed that our year zero was good enough, and there is no year zero, but we picked somebody about 800 AD, picked a reference year, and that's just what we got. So it's easy. Physical time is easy because we can do math on it. We can add intervals. We can compare order. It's one-dimensional. Moving in one dimension is easy. Time zones don't exist. By the way, this was kind of the annoyance that set me off on the path towards giving this talk. Was people would talk about a timestamp in a time zone, and they'd give them a blank look and say, "That doesn't make sense. What are you talking about?" An absolute physical time is not in a zone. It's always now everywhere, as they say. So there's a few pitfalls that don't involve the calendars here that we have to watch out for when dealing with physical time. There are people in this room, no doubt, who intend to still be employed in 16 years from now. I do not. Those of you who are, have fun. The 32-bit Unix time key is going to overflow. I can see from who's laughing and who's making grimaces and faces that whose problem this is going to be. I know that Linux and friends are all moving to 64-bit. Just so you know, there's a lot of 32-bit embedded platforms out there, and MySQL timestamp type is 32 bits secretly. Maybe they'll get around to fixing that.
I think that's 16 years. 16 years.
Yeah, they get 16 years to fix it. That's what, 2 bits a year? Handful of other things. Like I said, it's a physical measurement, so it's imprecise. The system's going to adjust it constantly. You can't count on it just counting up all the time. You can't count on it to have any better resolution than, well, a second at best. And it could bounce around by hours. There's also a little matter of leap seconds that I will digress into at the end of the talk because it's not really relevant here, but it's interesting and you should know about it. And of course, it's useless. Nobody's going to look at a Unix timestamp and think, yes, this software is done. It's working right. Our customers live in the world of calendar and clock time. Calendar, clock, it's the same thing, really. These all come from the cultural need to count various culturally relevant things. Days, seasons, moon season, reigns of kings, religiously significant intervals of days. And other than the days into weeks thing, none of these divide nicely into each other. They're subjective. They're all based around your local tribe and royal seat, as it were. If you start traveling, the days drift off, the seasons flip. If you go far enough north or south, your different high priests are going to have different ideas about which numbers are holy. Maybe 7. We've kind of settled on 7. Romans used 8. Ancient China used 10. French Republican calendar, if you've ever heard of that, uses 10. Soviets experimented with 5 and 6 day weeks, which was, when I learned about this way back in the day, it was sold to us good little Christian children as the Soviets are trying to make Sunday illegal. Which, fair. That was part of the deal. They kept the 7-day week for religious purposes, but they would divide a workforce into 6 groups, each of which would have a different day of the 6-day cycle as their weekend.
Collectivization?
Yeah, so that nobody's weekend lines up reliably with Sunday, and they could keep the factories going all the time. And of course, year 0 is the ascent of a king is a popular year 0, and nobody has the same king. And I mentioned this is a mess. The modern strategy that we've kind of descended on to handle this mess is the concept of a calendar system, of which there are 16 known to Apple alone. We like to pretend Gregorian is the only one. If you want to assume that Gregorian is the only one, you have to specifically say that in your code. There is also the concept of a time zone, which is a local jurisdiction that defines how we create a wall clock time and a day counter in a place. It is not just an offset. It is the set of all rules for taking a physical time and turning it into a culturally meaningful wall clock time. Here's a map. Anybody seen this? This doesn't even go into the DST rules. This is just the basic non-DST offsets. There are about 38 of them, not 24 like you might expect. Lots of places have non-integral offsets, 15 minutes, 30 minutes. There is another fun wrinkle that we'll see if we look at the South Pacific here. One good surprise, the only good surprise on this map is that GMT minus 12, let's see if I can mark this up, GMT minus 12 is uninhabited. Those 2 islands are rocks. The U.S. Park Service visits them once a year. Nobody lives there. There's no internet. You don't have to worry about customers there. It's the only good news I got. You will notice also that there's a plus 13. Why is there a plus more than 12? There's plus 13. Kiribati and Samoa there. Right next to American Samoa, which is minus 11, you will notice that 13 and 11 make 24. Samoa and American Samoa use the same wall clock time, but a different calendar day. They're a short boat ride apart. People go back and forth all the time. It's Monday here, it's Tuesday here. The same instant, if you ask your computer for a physical time and it gives you a Unix timestamp, that timestamp is a whole day off in a tiny little area where people live and travel and work, and where there are potential customers. These also update annually, by the way. There's a change to the time zones file pretty much every year. Time zone or DST rules get legally funged, and everyone has to update. Countries invade other countries. Look up Europe/Kyiv zone versus Russia Standard Time. That one's still up in the air, unfortunately. Hopping to the east over the zone. Plus 14, what? Kiribati, the country there, had a chunk of their islands, the line islands, in the Hawaii time zone. which meant half the country was a day off from the other half. They got sick of that. So not tremendously long ago, I didn't jot down the year, they skipped a day. They skipped a December 30th, and so now they are in the plus 14 zone instead of the minus 10 zone. Looking back at the minuses, you see that the minus 12 is uninhabited, but minus 11 definitely is not. American Samoa and Niue there are definitely people there that we have to think about. So the implication here is that over the entire Earth, there is never an instant when it is all the same calendar day. And there are a couple hours when there are 3 calendar days, all of which are now. So the old trick of someone who will remain nameless once thought of the clever trick of storing dates as GMT noon. Because obviously the prime meridian, when the prime meridian is noon, it's the same day worldwide, right? You cannot do that, I'm sorry. There are some other weirdo calendar systems out there. Yeah, that's enough about zones for the moment. Calendar systems, when was the last country that adopted Gregorian calendar? Anyone know? When did that last happen? Decade? Century? It was 2016. Saudi didn't adopt Gregorian officially until 2016. Before that, the last one was Turkey in 1927. Most of the calendar systems that are actually in use, with the big exceptions of Islamic and Hebrew calendars, are Gregorian plus a different year zero. This makes them somewhat dangerous because, like with my example with the Buddhist calendar, you don't actually see that there's a problem until something that involves the year happens. And all of a sudden, 2 people are seeing 2 different views of the world. The Hebrew and Islamic calendars have lunar months, or in the Hebrew case, lunisolar, which means they're lunar plus a periodic adjustment month. Islamic, I think, uses pure lunar. Any Muslims in the audience, please correct me. So not too many people will use that as their system default calendar in a way that will affect us, for better or for worse. But they definitely use the Buddhist or Japanese calendars. So you'll have to watch out for that. By the way, anyone who has to worry about dates in the distant past, there is a thing called the Julian calendar that you might have heard of. You can, for dates earlier than, did I write it down? September 1752. That is where we took out all of the extra leap days that Julian calendar had been giving us and pushing the year out of sync with the seasons. If you, on a Unix system, if you type cal September 1752, you will see a block of days missing out of September. That's when we changed. Different locales made the changeover at different times. If you've read the Neil Stephenson Quicksilver books, that's a plot point in one of them when France and England were on different calendars for several years. But we need to work in this space. We can't just throw over to absolute time and just treat calendar dates as a matter of formatting, because we need to model them. People think in calendar dates and times. Birthdays, legal deadlines, business transactions. People aren't going to come to work at a certain Unix timestamp. They're going to come to work at a time on the clock, on the wall of the work. They have to match. Fundamental thesis being, when you say date, you mean one of 2 radically different things. You very, very rarely have both. That's a picture of an atomic clock on the left there as a stand-in for physical time, since the atomic clock is just counting as precise a fixed size second as we know how to make. And the one on the other side is a ancient Egyptian royal calendar. Our computers give us, let's see, how am I doing on time? Got about 20 minutes? 15? Our computers give us data types to deal with the situation, and they fuzzily map up with these two categories, physical time versus calendar time, but not well. You have to know, whatever data type you happen to have in your processing, you have to know which flavor of actual concept you really have. And I'll show you a few of the exceptions here. The way things are supposed to work for actual physical time, we've got an epoch offset. These are the popular ones. They're not in a zone. They're physically sampled from a sensor in your computer. Unfortunately, sometimes, often, they get used as a stand-in to store a year, month, day, hour, minute, second. And they do not have a year, month, day, hour, minute, second outside the context of particularly chosen state, a calendar system and a zone. People do it anyway, and it works until it doesn't. Interesting special case here. No doubt you have seen strings like this go by in your JSON. When you have a string that looks like 2022 05 27 T 16 01 29 Z, do you actually have an hour? A particular hour? Do I actually know 16 as being a meaningful 16 to the user? Or even a 27 as a meaningful 27 to the user? No, I have a description of a particular hour, minute, second at the 0 meridian that the customer is probably not at. So outside of good documentation and further information here, I don't have a calendar time when I have an ISO 8601 string. I have a physical point I have a point in physical time. And my platform's tools will hopefully convert this unambiguously nicely to a Unix offset or a Mac double offset time interval or whatever it is I need. But if I try and turn this into a May 27th, it's about a bit more than 1 in 2 chance I'll get it wrong. Same deal with the other two. They have the suggestive presence of a -5 or a +1 down there. They all represent the same physical time. And I might look at that -5 and say, oh, well, obviously I have a date that was sampled in the central time zone. Or do I? -5 could be Eastern, could be Central during daylight, could be various places in Canada, could be somewhere in South America that has inverted DST. When you have an offset, you do not have a time zone. Just don't make that mistake. Over on the other side of things, calendar side, there is limited acknowledgement in platforms that yes, we do need to have 2 separate models for these 2 separate concepts. So Apple has, I think, the best one. It's a free-form collection of any fields that you might happen to have. You can set the year, month, day, hour, minute, second, or any subset of those. You can set a zone or not. You can set a calendar era or not. It's very flexible. However, Apple kind of face-planted in that same structure, the NSDate components, is also used not only for a position in calendar space, but it's also used for counts of individual units. If I make one that says May 13th, that could mean May 13th, or it could mean 5 months and 13 days. Whoops. And which one it means is entirely contextual based on your use of it in the APIs. If you don't do that, it won't hurt too much. Unix has struct TM, similar concept. Painful surprises in that not all of the fields are meaningful for a reverse conversion. If you fill out a struct TM and you put in a zone, you will be surprised to learn that the system default zone set in your environment is what gets used and not the zone in the struct. That is not the only surprise that struct has in store, so read the man page carefully when you're doing reverse conversions with a struct TM. I'm not going to go into Java util calendar too much, except to say that it's awesome. And it's the only one that does not require you to detour back to a apparently physical time to do calendar math. If I'm trying to count all the days, or start at a day and then iterate counting days up, Apple and its calendar makes me use the calendar to convert a day to a timestamp and then advance that timestamp by days. Bad habit. That's a round trip through the types. So that's an example of what I meant when you say you have to know at every stage what you actually have rather than what you seem to have based on the data type. I would consider that a case where the timestamps it gives you back aren't really timestamps. You're not going to do comparison to real events with them. Instead, you're going to use the calendar to do date math, to move them through the calendar space. MySQL is a little more rigid. You can have a year, month, day, you can have an hour, minute, second, or you can have both. Back here, you notice they also have a timestamp. Timestamp in MySQL works almost exactly like a date time, except a lie from the docs here, just because I like airing dirty laundry. MySQL converts timestamp values from the current time zone to UTC for storage and back from UTC to the current time zone for retrieval. This does not occur for other types such as datetime. They do no such thing. They convert your year, month, day, hour, minute, second using the local time zone into a 32-bit Unix timestamp. And they store that. There is no time zone. It's an absolute time. Then on the way out, whatever your default time zone is set to, there's that global state again. You got to look out for it. You pull it out and you get something that's a year, month, day, hour, minute, second. Is it the same one that was put in? Mm-hmm. So if you, unfortunately, MySQL does not have a type to let you store year, month, day, hour, minute, second zone, which would be the ideal solution. The sucker solution would be a year, month, day, hour, minute, second offset, which would be worse than nothing. Because as we've seen, an offset is not a zone. But we do have to convert. So in practice, the real rules are get a handle on that global state. Don't use the default calendar and just assume that it's going to be what you think the default calendar should be, because some customer is going to disagree with you. Make the calendar system and the zone both explicit. You will often have to maintain two of these. A calendar that the user uses as chosen on their device, that's the one they want to see dates in. If somebody picks the Buddhist calendar, they want to see dates in the Buddhist calendar. So you have to get them right. You will also, if they do that, you will also need to maintain a sort of a reference calendar, the one that matches the model that the rest of your system is going to use. Your backend almost certainly uses standard Gregorian. You might have the 0 meridian as your standard time zone. So you need to make yourself a calendar that has those settings. We'll see an example of that in a minute. Java, by the way, has 3 separate date API libraries. Don't use the first one. They freely admit they screwed that up righteously. The Java util date type has fields like year, month, day, none of which a Java util date actually has. They're all synthesized on the spot using shared global mutable state. Don't use them. They're good only for debugging to a degree. The Java util calendar stuff was an attempt at fixing that. There is newer API in Java 8. Any Java heads here? Based on Joda time, that's even better. They made that jump after I got out of the Java game, so I can't tell you a lot about that. When I say round trips, the Apple calendar APIs require you to jump back into physical time offsets to do calendar math. That is an unfortunately required round trip. Don't do that where you don't have to. If you take a timestamp and turn it into a year, month, day, and then turn it back into a timestamp and then try to do timestampy things with it, you're gonna have a bad time. There was an Apple WDC talk a few years ago that I went looking for, and they've taken it offline, that described ways of doing calendar math with the stuff. They specifically caution you against, if you're iterating days, they specifically caution you against making a date object and then advancing it by one day by the calendar. Because that date might represent an hour that doesn't exist in the next day. If you're advancing by days and you happen to cross a DST boundary, what happens? Nothing good. You want to start with your first one and then increment it by 1 day, 2 days, 3 days, 4 days. That way you're not round tripping your type into calendar space and into physical space and back and back and back. And there's a much lower chance that things are going to blow up on you. And in general, don't pretend you have a year, month, day when all you have is a timestamp. Don't pretend you have a timestamp when all you have is a year, month, day. Mitigation strategies, how are you doing on time? Do we have 10 minutes-ish? Okay. 5? Oh, joy. Okay, I'll wait till someone glares at me from the door. Let's mitigate one of these. Let's mitigate the timestamp standing in for birthday. Say you look in the database and you find this garbage. We have to fix this. We've got a large deployed user base that we can't update all their apps at one time. How are we going to store what we mean without upending the apple cart? Best fix, obviously, store a year, month, day. Just explicitly. Make it self-documenting, make it exactly what we need and mean. A hack, unfortunately, that works if you're careful is to store the year, month, day with an hour of 11 a.m. in the 0 meridian. This comes the closest to having a timestamp that represents a calendar day worldwide. It does not. You miss out on Tonga and Kiribati. Unfortunately, their birthdays get screwed up. Fortunately, that screw up is only for the old code. You then rewrite the code that uses this field correctly, i.e. parses that string with a 0 meridian calendar and pulls the year, month, day off of it, and deploy that. Most of the world doesn't know a thing until they update their app. Tonga and Kiribati, unfortunately, say their birthday is off by a day. It's unfortunate, but it's the lowest impact solution I could find. You'll notice I picked 11, not 12. That is specifically for the New Zealanders. The plus 12 zone. When you see code in here, 86400 is a good magic number to tell your linter to warn you about. Code that contains that number does not pass code review unless the author has a real good excuse. 86400 is the number of seconds in a day, usually. And as we've seen, when you assume knowledge like there are X some things and a something else, you're wrong. Just don't ever assume you're right, even on weeks. Just don't. So counting up 24 hours or 8640 second hours, or striding by 3600 or 8640 second days or 3600 second hours, or even some crazy people will even code that whole 30 days of September, April, June, and November business right there in the application code and try to count month days. Just don't. You won't get the leap year rule right. The mitigation here is obvious, and this one is the conventional wisdom: use your platform utilities. On a Mac or an iPhone, Java-line calendar, ask it for a Gregorian calendar in the 0 meridian, and have at it. You can tell it, okay, here's a birthday. You can tell me when noon on that birthday is in Greenwich, and I can start doing calendar math with it, like finding the day after it, or even enumerating all the days in that month. This is how you do that. You ask the calendar, what's the range of days in this month? Tick, 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 tick. And then print out your calendar. Here's a little gotcha we touched on early on. You see here in these two pictures records from my Hydration, my water tracking app, and from the Apple Health view of the same data. Those columns are showing you how much water I drank on a day. If I were to take my phone and my bottle off to Mumbai, the right-hand one of those would go all kaflooey, because the Mumbai days do not line up with central time days. And this hydration app and Apple Health took opposite approaches to mitigating the incorrect assumption that, oh yeah, a day is a day and it's the same for everybody. Burp, burp, burp. So we made the first two options here. They're both valid choices, but us and Apple, we chose them differently. We at Hidrate decided that a sip of water was associated for now and forever with the calendar day, year, month, day, that it was locally taken in. And no matter where in the world I go, if I look at June 4th's hydration sometime in the future, I will see the same sips that I would see at the end of today. Apple took the repaginate approach. They store my water records at their actual physical time in the nice, intuitive, easy, one-dimensional space. And then when I go to look at them with the Health app, it uses the current calendar to allocate those on the spot to a local calendar day. So if I go back into history and look at when my activity was happening, I would see, on local days, nice, drank water during the day like I'm supposed to. Go back to when I lived in Minnesota, and I would see, hydration, sleep, hydration. And it would be it wouldn't match up with the hydration app. Both would be correct from a certain point of view. Thank you, Obi-Wan. Or finally, if you are trying to execute the concept of grouping and paginating things by day, take it back to your product owner and re-engineer things. Just work through the requirements, get them to understand what the situation is, that the world does not revolve around them. If it works on their machine, it does not necessarily work on the world's, and figure out what exactly you do want to store. Points in time are not calendar dates. Don't pretend that they are. When you have to, use your platform's date tools, but understand their limitations. Don't assume that you have a time offset when all you have is a year-month day. Don't assume that you have a year-month day if all you have is a time offset, because you don't. They are not fungible. This goes hand in hand with use your platform tools, but never assume that there are n somethings in something else, because there will be an edge case where you are wrong. All these amateur calendar makers throughout history have cobbled together a real patchwork, and you haven't memorized it. And almost, I personally don't think almost is good enough. I think if it works on my computer and most of the computers within a time zone or two of here, no, that's just waiting for the problem. That's leaving the problem in there. You know it's going to happen sooner or later at the worst possible time. And calendar bugs have a nasty habit of cropping up only in customer situations, because you can write a test case that exercises this stuff till the cows come home. And it won't have that weird combination of situations. Oh, they're boating across the straits in Samoa, for the weekend, and they expect their app, whatever it was, whatever service you're providing them, they expect that to work, and it blew up. It did something subtly wrong. That's the summary. Has anybody got a date horror story we can go into, think about, analyze, or do you just want to look at the cute bird pictures? Go. Okay. Okay. She's a cute bird.
Do you have any advice on mitigating daytime issues for daylight savings time?
Daylight savings time.
I know that, it wasn't me.
Of course not.
I've been affected by issues where we do some sort of daily processing. Everything works fine. At midnight every night, things get picked up. All of a sudden, you get an alert that things weren't being picked up right around the switch.
Right. Cron has the problem where you're trying to define an event, a thing that you want to happen physically, in physical time, but you have to specify it using your month, day, hour, minute, second. And as you discovered, if that hour happens to be one of the ambiguous hours, and a little DST trivia for you, we do our changeover at 1 a.m. We either hop from 1 a.m. to 2 a.m. or we repeat the 1 a.m. hour. Guess what Brazil does? Brazil does it at midnight. Anybody who uses midnights, physical times that happen to be midnights for doing their calendar math, it's going to blow up in Brazil. So what it comes down to there is, do you want these events to happen at a certain clock time or at a certain interval? And
I think, if I'm reading the product owner correctly, then I think he's told me before, it's just midnight wherever you are. Right?
Midnight local. He's assuming that there's a midnight wherever you are always, and he's never been to Brazil, has he?
There's ambiguity, but I think in the middle of the night, in the United States,
right,
this should be processing.
Right. I think you could get a basically correct behavior there by choosing a reference day or a reference point in time, a midnight that you know exists, and using the calendar functions to add a certain number of days to it. And don't worry too much about hours. Or rather, use hours to define your reference starting event. I'll just bet you in the cron man page, I'll just bet you there's a subclause in there that describes what to do when a particular hour doesn't happen or happens twice. But obviously on a DST changeover, if you've got an event scheduled at 1:30 a.m., you don't want that to happen twice or not at all. You want it to happen either at the first 1:30 or at 2, basically. 1/2, which is the same time. Go for it.
Would you recommend any resources on how to take a given geography and look up like a conversion to UTC? Because I work with data that.
Given geography.
So like
if you have
Arizona.
If you have a customer lat long, you do not have a time zone.
Yeah.
I'm sorry. Arizona, you may know, does not observe daylight savings. There is a large Native American reservation within Arizona that does observe daylight savings. And within that reservation, there is the territory of a particular tribe that itself has opted to, again, not observe DST. If you have a GPS sample for a user, you can't. The best you can do in that case is to ask the system what the user has chosen for their default time zone and save its Olsen ID, which is the closest thing to a primary key for time zones that we have.
I'm looking more at enterprise data.
Uh-huh.
So, for example, you might have given warehouses across the country.
Uh-huh.
And for that, then it'll say, oftentimes the system data will be stamped as GFT or it'll be stamped as CST,
Right.
but it might just have no stamp at all. And so like
Okay.
I'm not looking at, you know, that one immediate
Okay.
information, right? I'm looking at,
Right.
I know exactly what town it's at.
Okay, are you trying to model the physical time that an event happened or the legal time in which it happened?
I'm trying to standardize events to the same time. So like, if I have two different time stamps, I can somehow know that this one happened 2 hours before this one, even if they were different.
Okay, if you're talking about before, then you're talking about physical time.
Yeah.
That basically means you have to either convert things to GMT or use a epoch offset, and just that's the source of truth.
So would you know of any resources that would be, excluding the edge cases, fairly reliable?
I think you're going to have to do it yourself. Your model is going to have to include the concept of, well, most computers will give you a local physical time. You could trust that, knowing, as you do, that physical time sensing is inaccurate and can be, fudged.
Yeah, there's a lot to